Hello guys, and welcome back to a new video. Today's video is going to be on something called reduction formulas. So basically, these reduction formulas can be very helpful when integrating trigonometric expressions to powers. So let's say the integral of sine 4x dx. So this is going to be quite difficult to work out by itself, like just in this standard form here, but there is a way we can simplify this. Now, sine to 4x is actually going to take a really long time to do, so we'll just do sine to the 2x for this example. Okay. So, the reduction formula for sine is the integral of sine to the n is equal to negative 1 over n cosine x multiplied by sine the n minus 1 plus n minus 1 over n and the integral of sine n minus 2 dx. So that is this here is the formula for sine integral reduction. So in this case here, sine to the 2x, the power is going to be the n, okay? So in this case, sine to the 2x, sine to the power of sine x to the power of 2, the n is going to be 2. So we can use 2 for n in this case. Okay, so let's do this. So that means that the integral of sine 2x, sine x squared, is equal to negative 1 over 2 cosine x sine of 1x plus n minus 1, which is going to be 1, over n, which is 2. And the integral of sine to the n minus 2. In this case, n is 2, so it's sine to the power of 0, which is 1, as it is a positive. So, now we can go ahead and work this equation out. Okay, so we can simplify this to negative 1 over 2 cosine x sine of x plus 1 over 2 x. Okay, so this can be our final answer if we really want, but we can change this sine x, cosine x, to, well, 2 sine x, sine 2x, sine 2x is equal to 2 sine x multiplied by cosine x. So you may see that we have a sine over x cosine x here and a cosine x sine x over here. So they're actually the exact same things. So if we can just isolate the sine x cosine x in this here, which will just involve getting rid of the 2, we can put that in here. Okay, so let's do this. So to do this, we're going to need to divide by 2. Because 2 sine x cosine x divided by 2 is going to be 2 over 2 sine of x cosine x, which is the same as 1 over 1. So that will be sine x cosine x. So we just have to divide both sides of the equation by 1 over 2. So let's do this. Divide by 1 over 2. Divide by 1 over 2. So that means that 1 over 2 sine 2x is equal to sine x cosine x. Okay, so let's do this. So that means that negative 1 over 2 multiplied by 1 over 2 sine 2x plus 1 over 2x plus c is equal to sine squared of x dx. Sine squared of x dx. Yep, sorry. Now we can just multiply the negative 1 over 2 by 1 over 2 sine of 2x. Sorry, that is a bad 2. I'm just going to redraw that. Okay, so negative 1 over 2 times 1 over 2 sine x is just going to be equal to negative 1 over 4 sine x 2x plus this part here plus 1 over 2 x plus c. So that can be our final answer for sine squared of x dx using integral reduction. Okay, this is going to be our next equation. It's a bit different as it involves cosine instead of sine. So the formula for cosine instead of sine is going to be, so the integral of cosine to the n, okay, is going to be equal to, instead of negative 1 over n, it's going to be 1 over n multiplied by sine of x cosine n minus 1 plus n minus 1 over n integral of cosine n minus 2 dx. Okay, so this is the formula for the integral reduction of cosine instead of sine. So let's go ahead and work out this question using it. Okay, so in this case, n is obviously equal to 2. So let's use n equals 2. Okay, so we can see that 1 over 2, so this is equal to 1 over 2 sine of x multiplied by cosine to the 1, because 2 minus 1 is 1, plus n, or in this case 2 minus 1 over 2 integral of cosine to the 0 x dx. Okay, so we'll go ahead and simplify this as much as possible. So we get 1 over 2 sine of x cosine x plus 1 over 2 integral of 1 dx. Okay, so this is going to be equal to, we'll simplify this again, to 1 over 2, and then remember what we said earlier about sine of 2x equaling 2 sine of x cosine x, and then we divided both sides of the equation by 2 to get 1 over 2 sine of 2x is equal to sine of x cosine x. So we'll put this into our equation for sine of x cosine x to get 1 over 2 sine of 2x. Okay, and then plus 1 over 2 x. Great. So our final answer is going to be 1 over 4 sine of 2x plus 1 over 2x plus c. Now, it's very important to not forget the plus c's, as they are the constant of integration and you must have them every single time. So that is the integral reduction of cosine squared of x. Okay, this is going to be our last equation for today. The integral of sine to the 4th x dx. Okay, so do you remember what I said before about the integral reduction of sine of x? Okay, well, if you didn't remember, that's fine, because it's the integral of sine to the n of x is going to be equal to negative 1 over n cosine x sine to the n minus 1 x plus 1 over n minus 1 over n integral of sine n minus 2 x. Okay, so this is going to be the integral reduction formula for this equation, as this is in terms of sine of x. So we're going to have to use this thing right here. Great. So that means that this equation here is going to be equal to negative 1 over 4 cosine x sine to the 3rd x plus 3 over 4 integral sine squared of x. Okay, so already you might be able to see that this one will be a little bit more complicated than the last one, as in the last one, the cosine x times by sine of x, which was this one, became 1 over 2 sine of 2x. Whereas in this case, we have cosine x sine to the 3rd x, which doesn't have a neat little formula for a sine of something x. So we're going to have to turn this sine of x, sine cubed of x, into sine squared of x times by sine of x later. And you might also be able to see that this here doesn't just become the integral of 1 dx. So we'll have to do the integral of sine 2x dx. But luckily, earlier in the video, we worked out the integral of sine squared of x. It's right here. Negative 1 over 4 sine of 2x plus 1 over 2 x plus c. We don't actually have to incorporate the plus c when you're multiplying it. So basically, you don't have to multiply the plus c by like 3 over 4 or something, because the plus c changes and it's there as a constant. So yeah. Okay, so let's try and simplify this as much as possible. Okay, so this is going to be equal to negative 1 over 4. When you do these equations, I suggest that you go and focus on one thing at a time. So don't be trying to do like two things at once, like the sine and the sine cubed of x and the 3 over 4 integral of sine 2x dx, because then it can get confusing and you can mess up if you don't do it properly. So first we'll start off by doing this part, because I just like to do the integral parts first to get all the integrals out. So let's do this. Cosine x sine cubed of x plus 3 over 4. Now we have to put in the integral of sine squared of x dx. Sine squared of x dx is up here, and the answer is here. Negative 1 over 4 sine 2x plus 1 over 2x. Okay. Negative 1 over 4 sine of 2x plus 1 over 2x, sorry, plus 1 over 2x. And then because we've integrated, we add the plus c. So basically when you don't have a integral in your equation anymore, you can just add a plus c. Okay, so let us distribute the 3 over 4 to the negative 1 over 4 sine of 2x plus 1 over 2x. Okay, so just add in our first part of our equation. Now we distribute. 3 times by negative 1 is going to be negative 3. So we'll just put in this first. Actually, just go straight like this. Negative minus 3 over, and then 4 times 4, 16, and then sine squared of x, okay? Plus, as positive, whereas this one was like a negative positive, and a negative times by a positive is a negative, and a positive times by a positive is a positive. But also, don't forget that a negative times by a negative is a positive. But that's irrelevant right now. Okay, so 3 times 1 is going to be 3. And then 4 times 2 is going to be 8. So this is going to be, well, this is not the fully simplified answer, but if you really want, you can leave this as your answer. So now we just add our plus c, and we'll move on to this part of the equation. Okay, so remember how earlier I said we're going to want to change it to a sine squared of x multiplied by sine of x. The reason we want to do this is that we'll get cosine x sine of x. Okay, and remember that before, this was 1 over 2 sine of 2x. So it will be very beneficial of us to do this. It will make the multiplying a lot easier. Okay, so now we have to do multiplied by sine squared of x. Because remember that sine of x multiplied by sine squared of x is sine cubed of x. And then we just add the rest. 3 over 16 sine of 2x plus 3 over 8x plus c. Great. So we can actually rewrite this sine squared of x as 1 minus cosine squared of x. Okay? Or we could write it as 1 over 2, okay, 1 minus cosine 2x. So these are the ways that you can, these are the things, just some of the things you can turn sine squared of x into. Okay, so we'll turn the sine squared of x, into 1 over 2, 1 minus cosine 2x. Okay, so let's put this in for sine squared of x. So negative 1 over 4, and then cosine x, sine of x, is actually going to be 1 over 2 sine 2x. Because before, remember how we found that 1 over 2 sine of 2x is equal to cosine x sine of x. So let's write that in. 1 over 2 cosine 2x. Not cosine, sine. Okay, and then 1 over 2. 1 over 2, and then we'll do 1 minus cosine 2x, and then minus ... So ... will be this part, because we're mainly focusing on this part right now, so we don't really need to write this in every single time, and it will just make it a lot longer because we'll have to write on a whole nother line as well. So we'll just do this for now, and then we'll just add this at the end, because this is as simplified as it can be for now. Okay, so we can move these into the front, okay? So it's going to become negative 1 over, and then 4 times 2 is 8, and then 8 times 2 is 16. So negative 1 over 16 multiplied by sine of x, sine of 2x, sine of 2x multiplied by 1 minus cosine x, cosine 2x. Okay, and then minus ... Okay, so this is going to be negative 1 over 16, okay, of sine 2x minus cosine 2x sine 2x minus ... Okay, so right now you might be able to see that we have a cosine 2x and a sine 2x, which is sort of like cosine x sine of x, and cosine x sine of x is equal to 1 over 2 sine of 2x. Okay, so you might realize here that these x's, right, they're being multiplied, okay, when they get to the sine 2x, okay, multiplied by 2, that is. So if we assume that this rule is also true for cosine 2x sine of 2x, this will be equal to 1 over 2 sine of, and then 2x doubled is 4x. Sine of 4x. 1 over 2 sine of 4x. So we can actually put that in here. So we get negative 1 over 16 multiplied by sine 2x minus 1 over 2 sine 4x minus ... Okay? So here we can actually go ahead and distribute negative 1 over 16. So let's do that. So this is going to equal negative 1 over 16 sine of 2x, right? Plus, because negative multiplied by a negative is positive, 1 over 2 times by 1 over 16, and that is 1 over 32 sine of 4x. Okay? Okay. Now, at this point, we can add in the rest of it. Minus, and the rest of it is negative 3 over 16 sine of 2x plus 3 over 8x. Negative 3 over 16, right? Sorry. Sine of 2x plus 3 over 8x. Three over 8x plus c. Okay, so here, this is almost finished, but there's a sine 2x here and a sine 2x here. So we can try and combine these expressions. So they both have the denominator of 16. So we can do negative 1 sine 2x minus 3 sine 2x all over 16. So this is going to equal negative 4 over 16 sine 2x, which in turn is equal to negative 1 over 4 sine 2x. So let's add that in, and that should be the end of our equation. Equals 3 over 8x, right? Minus 1 over 4 sine 2x plus 1 over 32 sine 4x plus c. Okay, so that is the end of this equation. So thank you for watching this video. I hope you learned something new about reduction formulas for trigonometric integration. So I'll see you